So what you can easily do if you want to have the panic mode, you can override it.
Interesting.
Actually, what I like.
This is a wicked fiddler.
Yeah, absolutely.
The button.
Yeah,
I love the button.
The sound, the snap sound.
I was actually. What's interesting.
Okay, I'm Daniel, and we're at the EDELRID home base, and my part here in the company is I'm part of the development team. And today I'm here with Johnny from Canada, and
hey guys.
we're here to talk about the new belay device, the Pinch. Probably, Johnny, some background to your side.
Yeah, so ISA certified arborist for 21 years. Been a rock climber for 26 or so years. Started when I was just a kid.
I just calculated, so you started with 9 then probably?
My 11th birthday.
11, that's it, all right.
My 11th birthday was to go rock climbing. Yeah, and I just fell in love with it. And then of course, like from rock climbing, inevitably you're gonna end up getting into some way to make money by climbing. So it turns out you can make money climbing trees. Yeah. So I figured that'd be a good choice. And then pursued an education in that and started a company, and you know, here we are 16 years later of that company. We're still in business, thank God. Things are going quite well. And then later in life I went and got my rope access ticket as well. So I'm in the SPRAT system as a rope access technician. So a little bit of juggling. I mean, there's many tasks, there's many sports that I do, but they all have, I guess you could say, like complementary skill sets.
But you're still in sports climbing as well, right?
Yeah, so I still climb. I really like to set new routes. I like to develop new routes. I like to go to places where people haven't already been. Like that's what really excites me.
Yeah,
and
also multi-pitch?
Oh yeah.
That's the best.
Yeah, so sport climbing, trad climbing, developing routes, even just alpine travel, all of that type of stuff. And the beauty of that is you know, I'm also into parachutes. So being able to get anywhere on a mountain is pretty helpful when you're trying to establish exit points, which is another thing that I've done. So quite a bit of base jumping and skydiving in my background. There was a period of time where I was a professional skydiver, so I actually taught wingsuit skydiving specifically in a couple drop zones in California. But it's just, you know, one fun thing after another. And my whole approach, you know, from the very beginning of all the sports that I was getting into, they're literally just a vehicle for exploration, right? So I got really heavy into mountain biking. That turned into rock climbing because eventually you find cliffs that are way too big to jump off of with your bike. So you have to figure out how to play on the cliff. So you learn how to climb. And then you get to the top, and you know, eventually you climb big cliffs and you're looking down like 1,000 feet and you're thinking, that looks pretty fun too. So then I had to learn how to skydive so I could learn how to base jump. So it's just one thing after another. So I know how to do all of it. I would say that I would be, you know, a proficient climber and a proficient rider. And then, you know, I'm a decent parachute pilot. You know what I mean? I'm definitely not a professional anymore. But that's what, you know, a wife and kids and stuff will do.
Sounds like a fun life.
It is a fun life. I'm a full-time fun haver, right? Like I literally climb trees for a living.
Same with me.
That's pretty sweet.
I never come here for money.
No.
Yeah, okay, but we're here to talk about the Pinch.
Yeah, a new belay device.
It's a new belay device.
Yeah.
New belay device actually the biggest market definitely for us is the sports climbing, pure sports climbing, indoor and outdoor.
Yep.
And nevertheless, when we worked on a new belay device, it was clear that we want to have a very versatile climbing or belay device.
Sure.
So it definitely was clear it needs to be a brake-assisted belay device.
Okay.
Probably at that point we can directly talk about brake-assisted. What does brake-assisted mean?
Yeah.
And I think the most important when you talk about brake-assisted is that you know that you always have to keep control over the braking rope. So always one hand is keeping control of the braking rope.
Right.
This is what in the end results from the word brake assisted.
Yeah.
It only assists you. So as soon as you activate force on the braking rope, the cam or the mechanism in the device supports you to hold the fall.
Yeah, it's doing the work, but you have to do some work.
You have to activate
it. Yeah,
Exactly.
You actually have to activate it.
So that's why it's only brake assisted. It's not a fully automatic belay device.
Right. Yeah, in the past, I believe that I used, so long before I ever met you guys, I used a device that EDELRID offered. What was it called? Eddy?
Eddy.
Okay.
It's
which was interesting, right? Like it had a cam and it had an anti-panic feature and a handle and stuff, similar to some of the other stuff that was on the market.
One of the first devices on the market with the anti-panic function.
Makes sense. Yeah, okay.
I'm quite sure there were not too many before.
Yeah. And then And then years later, once I started to travel to climb, so I started to travel to rock climb throughout the States, like mostly desert season type climbing. And I remember seeing, you know, specifically the jewels, like, so the, so, you know, I always thought that those were a brake assisted device as well, because because unlike ATCs and other offerings, reversos, etc., they would actually hold the rope. And I thought, like, okay, well, this is interesting, you know, because there's the geometry of the carabiner that works inside that slot that actually pinches on the rope. So I was like, well, obviously they have that part of the market cornered, right? Because I wasn't seeing anything else that was working with that same concept. Now, later in work, you know, in the work end of things, I saw it from other offerings using just geometry to hold the rope, which I thought was really cool. But then I had wondered, you know, where are you guys going to come into the, I mean, I've always called this a camming device, right?
In terms of terminology, we try to distinguish between those two systems. The one is a geometry brake-assisted belay device, and the other one is a mechanically brake-assisted belay device.
Okay, that makes sense.
Here we have a mechanism inside,
right, because there's
moving elements,
moving parts,
spring parts, eccentric cams, and the other one is the geometry brake-assisted belay device, because it holds by pure geometry. There are no moving element beside the carabiner that is moving inside the belay device. So, but this is already one of the biggest disadvantages of those systems. The carabiner is part of the braking geometry. As soon as you change or exchange the carabiner oil,
it affects the way that it
exactly.
Yeah. And I've definitely found that. You know, like obviously your guys' oval carabiners work beautifully in there, but then as soon as you grab something that's more of a D shape or something that's asymmetrical or whatever, it's weird.
Even in our range, you will find carabiners that don't lock the rope in a dual device, for example. It's just, it creates a high friction, creates high friction, but it doesn't hold the fall by itself. And with a different type of a carabiner, it can be easily up to 1.5, 1.7 braking force. Camming force in the device.
How do you calculate that? Like, what do you mean by 1.5? Is that a...
So you put the rope inside the device, lock it with the carabiner, and start to pull without breaking hand.
Okay.
And then the device locks, or the rope gets locked between the device and the carabiner.
Okay.
And then the harder you pull, after a certain point, it will start to slide.
Okay.
And depending on the carabiner geometry, on a jewel, for example, you can easily create a variation between 0.4 kN braking force up to 1 kN.
Oh, okay.
So beginning from 50 kilograms, and then it starts to slide.
Yeah.
And then up to almost 200 kilograms where it starts to slide.
Only
dependent on rope and carabiner geometry.
Okay, so take for instance like the megajoule. Okay, if you put the perfect carabiner in that, and then
bruised steel,
and then load it
with a 10 millimeter
to
rope.
Maximum, right?
Exactly.
But so that device will slip. It won't be able to pull the rope into that slot enough to fail the rope.
No,
it will slip before it fails.
It will always slip. Exactly. And it will slip with the perfect rope, perfect carabiner. You can get up to easily 2 kN.
Okay.
But take a very thin, soft rope and a D-shaped carabiner, and you will get probably 0.4 kN.
Right, and now we're back to sort of the traditional ATC type feel.
Exactly.
Oh, okay, I never realized that.
And this is more or less where we were when we started the development on the new belay device. We said this is the big advantage of those auto tubes, and at least in the German-speaking area of the Alps, we call it the auto tubes.
Okay.
It's the geometry brake-assisted belay devices. The biggest advantage is they're cheap. They're easy to produce.
Yep.
They're lightweight.
Super light.
Quite easy to handle. It's easy to learn. The mechanism, it's way easier to...
Well, it's intuitive. I mean, like there's a giant thumb loop right there, and you just throw rope out of it, and your hand's already around the...
That's the point.
Yeah, and I fell in love with that device as soon as I saw it, for every reason that you just listed.
Whenever you try to teach people climbing or belaying, you'll find one of those devices to be the easiest to get people trained on it.
And what I loved, being that I would travel to climb, I mean, that's normal in my life now, but back in the day, you would find yourself in a new city, maybe it was raining, you would end up going to the gym, and then they would be like, nope, you can only use this device from that company that starts with a P or that company that starts with an M or whatever, right? And then they recognized the EDELRID device, and they were like, yeah, you can use that. And I was like, cool, like finally I don't have to jump through a bunch of hoops, you know what I mean? And I was like, okay, like these guys are legit, like, you know, like people are actually realizing them. And then I go to find out that you guys are like the longest standing, you know, gangster rope manufacturer in Europe.
We're there quite a long time now. We had 160 years this year.
I know.
160 years.
That is bananas. That's cool. I don't even think I've had a country for 160 years. I don't think Canada's been around for 160 years.
I found I will meet at my place tonight. The house is 400 years old.
Unbelievable. And are the walls as thick as everything else around here? Like the thing is still standing?
No. You will have a look at it.
Yeah, okay, cool. It's, I mean, you know, the Germans. You guys are known for your engineering, and you can tell why, right? Like you were telling me about this building, like 30 centimeters of wood.
Oh, massive.
That would be, it's unattainable in North America. Like if you tried to build that spec into a building, they would just shake their head at you. They were like, no, the economics make no sense, we won't do it.
Why?
Whereas here, it's not purely the economics, right?
Right.
It's about like the quality of it and the future and making something that lasts. And I just, I really appreciate that.
Thanks for that.
So maybe this will be like that too.
Oh yeah, this. At least we have this plan.
Yeah, we will eventually come back to this. We will talk about these things.
Probably we should.
Yeah. So what are we looking at? Like, I mean, I see this.
Yeah, this was
little.
I told you that the first belay device that I developed when I was in this company was the Zappomat, and it was not really, I don't know how many, some hundreds, probably some 2,000 pieces or so that we produced, and it was sold. And the feedbacks that we got on it was really positive. I mean, we didn't sell a lot of it, but the people who bought it, they were quite convinced and they liked it and still keep on asking.
It's adorable.
It's easy. It's an easy mechanism.
Yeah.
And this was one of the first prototypes where I thought of how to use the mechanism of the old Zappomat and putting it into a more updated or a more new device. Yeah, so we started to playing on different concepts. This was one of those things.
Yeah.
Then a very early idea that we came up with is this element. There are two interesting things, and the one is on this one we already had the idea
to eliminate the carabiner.
Exactly. Why you have an opening mechanism? You open the device.
Yeah.
And to put the rope in.
Yeah.
And then you close the device.
Yeah.
And then you open something else.
Yes.
To close the device that you just closed and link it to your harness. And we said, why not to use this opening mechanism not only to thread the rope and to get the rope into the device, but also use the mechanism to attach the device to something else that is not openable. For example, the central loop of your harness.
Yeah. Duh.
And through these steps we were already when we were working on this prototype. But what was also clear right from the beginning, you can also see already here, that we said we still need to keep the conventional attachment solution, because there will be people who don't like to use that, or there will be situations where it's of advantage to have a carabiner.
Right.
So we need to combine the direct link to the central loop or to an element with an option to link it with the carabiner.
Right. So this was the first device and the first iteration of a device that you know of?
No, there were intermediate steps before.
Oh, there
already.
were. Okay, gotcha.
There were intermediate steps of this concept already without this concept.
Oh, understood. Okay.
Yeah, the second idea I already explained a bit was to combine the mechanically belay or brake assisted belay device with the same handling like the auto tubes have.
Right, and so that's the thumb hook here. Yeah. Okay.
So this was and we actually have a patent on this.
Oh, really?
Yeah. Mm-hmm.
Oh, cool.
On this combination. So this element plus this element, we have a patent on this one.
Oh, cool.
And then later decided, we liked it, and it's a super safe concept and a super safe belay device.
There's just a lot to it.
That was it. Because this happens quite often to us, that we over-engineer things.
Yeah.
And we said, is it the device that we would personally buy?
Right.
And this is the point where we said,
I suppose you'd probably just go grab a megajoule and get after it.
Keep it small, lightweight, simple. I want to have it for multi-pitching as well, and should probably work in rope access as well.
Right.
And there is only disadvantage. So we thought of probably having this device and this element detachable, or two versions of it. And in the end, we said, no, let's focus on a simple device, make it safe and easy to use.
But still incorporate a different way of attaching it to the harness. Yeah.
Keep doing innovation in small steps.
Yeah.
And we offer now a device. The mechanism is well known. The patent is there since 30 years and it's expired almost 10 years ago.
Perfect.
So the patent is free to use. We decide it's a valid mechanism. It has proof that it's the perfect mechanism on the market.
Yep.
The patent is not valid anymore, so it's free to use.
Yep.
But we come with something new, and the small new step that we want to go is the direct attachment point on the harness.
For sure.
And the idea there is not really to reduce the weight of a carabiner or save the carabiner in terms of weight or price. The idea is to have better control over the device when it's linked directly to the harness.
Better control in what way?
In terms of belaying. When you're belaying a lead climber, you have to thread the rope through the device somehow.
Right.
Keep it under control.
Yeah.
And when you imagine you have your central loop, then you have the carabiner, and then you have the device.
Oh,
so
yeah,
the central loop is already
obviously
soft.
the carabiner can already move,
Then
plus
you
the
have
loop can move and twist.
Joint between the central loop and the carabiner, and the joint between the carabiner and the device. So everything is free to move. And
I know what you mean. Yep.
And we wanted to have it as stable as possible, directly fixed to the body on the harness. And this we managed by directly linking it to the harness with this opening mechanism.
Yeah, that makes perfect sense. You're eliminating connection points, and every time you have a connection point, you have another possibility for failure, but also you have possibility for play, right, and everything else.
Yeah,
that's interesting in that it's about control.
That's control.
So the major driver for this innovation was control. It wasn't weight savings.
No, it wasn't the carabiner. Okay. It was about how to make the handling of the device as easy as possible while belaying. And we found the play between the device and the body and the hand as being the major problem for keeping the device and the rope control.
Interesting.
So this is.
I suppose I never thought of it. Right, because you learn to do it.
Because there's always a carabiner there. There's always the rope, the device, the carabiner, the harness, and it's always been like that. That's why no one requests a different version of it. But the control is way higher when it's as massive or as solidly fixed to the harness.
Yeah.
The less play you have, the better the control over the device and therefore over the rope.
Of course. Yeah.
That's the one thing, and the other thing is what we found, that when you have the central loop is here, then you add the carabiner and you add the device, then you have the device about here.
And before you know it, yeah.
And then when you want to feed rope really fast, because your leader he wants a clip, the lead climber is clipping, so you can start to pull the rope here and pull to there, which is about 70 centimeters.
Yeah, and then you end up compensating always by dropping the device.
And then again you lose the control.
Right.
And in this way you're lower on the body, the device is directly lower, so you easily have 20 centimeters.
Yeah,
exactly.
Meter
you can easily get up to a meter of slack that you can give with one pull.
Well, like from arboriculture, we're always trying to get our devices as low and as tight as possible.
Absolutely.
Because when you're climbing, there's nothing worse than punching your pinkies into the device and then it's always up here.
Exactly.
And then also just the concept of having to take slack, right? Like ergonomically, it's way better to do this than it is to do this.
Absolutely.
Right? So having that
experience that mechanism as well.
Yeah, and we're always trying, we're now seeing carabiners that are shrunk. Like for that reason, because we need to keep things tighter. So being able to put this like literally right there.
It's 10 centimeters. That's quite a lot.
That's a huge difference. Yeah.
So that was actually the idea of the direct link the device to the harness or to an anchor point.
Yeah, brilliant.
So it's not about the weight saving or the carabiner saving. It's about keeping better control of the rope.
Right, and I see that you've figured out a way so that load is shared by both plates here.
Exactly.
Right.
The idea there is we have a locking mechanism on the side shell, so you press the button, you can open. When you close it, the side shell is locked. Nevertheless, we wanted to have some added safety there.
Right.
And therefore, if you link it to the harness, in this case, you open, you thread it in sideways, then you also would thread in the rope.
Yeah.
Now you close it sideways, And when you move it in the handling direction,
now it's under load and under tension, and therefore
and then you cannot open it anymore.
Right.
Because there is an overlap between the shells here at this point.
Yes.
And really to open it, you have to move it sideways again until this bar is free to move.
Right.
And only then you can really open the side shell.
Right. And at that stage, there's going to be some kind of slack in the system to accomplish that.
Yeah.
Right. Yeah, because when we were climbing last year in Squamish, like the EDELRID North America, all of the team, we met up and we went climbing. Flo brought one of these as a prototype, right? And I think it was probably one of these. Yeah. But that was something that I thought, because it's very little load share.
There is no, you see?
Very little.
Exactly.
Yeah. And I noticed that was a difference that you guys had made on this late. Of course, the latch was another obvious difference too. And
the idea behind that was that in this stage, we still had a three-way movement.
Yeah.
So you had to push this forward,
and then
this
the whole
backward,
plate,
and then this one open.
Yes. Yeah.
So it felt a bit, it was safer because of the three-way movement. And when we canceled this, because it was too complicated to open,
you needed to compensate with it for a little bit more. Yeah, that makes a lot of sense.
That was the idea, and this is where this lip started to exist to compensate this safety there.
I need you to walk me through the prototyping. Like, you know me. Like, I'm always trying to come up with new shit. It's just, but it's my nature, right? Like, I can't help it. You're like, I always look at the way that things are, and then I need to find a way to make them better.
We're quite good in prototyping.
Yeah, so I see that. So when I see things like this, like...
And we can do this in-house.
Yeah, you guys are banging these things out. Like, you come up with a concept, you go downstairs to the 3D printers.
Just print it or do a CNC cut or weld it or whatever.
So obviously you're designing this in probably a CAD program.
Yeah.
Okay, so how many of you, do you have a background in 3D animation and engineering, or is that something that you...
The people working on those, they are all engineers and designers. 3D design is like different programs that they are using. And then, in the first place, we work only on the functional side of the device.
Yeah.
So it's only 3D engineering.
Okay.
And then when we get closer to the product, we start to implement designs.
Of course.
And then it's a different program as well that we're using.
Yeah, so like this, obviously, right? Like,
this is the pure engineering.
Yeah, relatively rudimentary, right? We're dealing with stamped aluminum. And then obviously this was either bent or modified in some way to achieve your shape, and then it looks like maybe some 3D printing to just engineer geometry for handles and things. Even like when we were testing, I remember back in 2018 when we were prototyping the Megawatt, there's still 3D printed, right? And so here at EDELRID, you come up with, you sit around a table. This is how I imagine it. Okay, you sit around a table, then you come up with an idea. We need to make
First we open a beer.
Yes. Oh, this is key. Yes. Yeah. Or make a coffee from one of the 35 machines that you have in the
around here in the house.
Yeah. So in this case, we need to make a belay device that operates with a cam that we can attach directly to the harness. And then somebody else at the table says we should probably incorporate some sort of a friction slot. And then somebody else at the table says there should be an anti-panic. And then you throw all of these things into a pot. And then you figure out, well, there's parts of this that we really like, but there's some parts of it that we don't really need. So then you pare it down to the concept. So now at that stage you have an idea. And maybe you have some drawings, right? So then at what stage does it go from this concept with maybe just drawings to rudimentary 3D printed? Is that the next step, or are you guys going and grabbing metal and bending it?
Yeah.
Really?
Yeah, we're faster to the product. I think in the beginning it's a pure theoretical thing.
Yeah.
5-6 people opening a beer, sitting together, collecting the ideas, concepts, possibilities, options.
Right.
And then one person is the responsible person for the project.
And how do you decide who that person's going to be?
You know this game with the...
It's like rock, paper, scissors?
matches.
Oh yeah, okay, whoever draws the
shortest straw.
Gotcha.
Ah, yeah, right, in English it's the shortest straw.
The shortest straw.
Yeah, and George won in this case. He lost actually.
That's awesome.
He won this project.
So now,
it's dependent on...
But you're talking about a project that's going to be years. Years.
Yeah, this one was 5 years.
Right.
And we have like the people working here especially here in the hardware department.
Yeah.
They're always a bit specialized.
Oh, okay.
So when it's about complex mechanism, moving element systems, then George is the right guy. If it's more about design and optics and functionality in terms of ergonomics, then it's more Daniel.
Okay.
If it's helmet, then it's another person. If it's more application related, then it's Mosi, for example. So if it's totally crazy shit, it's like innovative as hell, then it's Elena. And so everyone has a bit his specialties.
Right. So when let's say you get it from a stage like this and then you delete certain parts of it and you think, okay, I think I'm ready for the next step, then you go to the next gangster in the building.
Exactly. Can happen that it happens that the crazy stuff is done in the innovation department.
Okay.
So when it's just about concepts, when you talk just about concepts and don't know how the product will look in the end and what type of elements or functionalities will be included, it's in the innovation department, and probably Elena is working on it.
Okay.
When the concept is there, when we know, okay, this is more or less the device that we want to do, then it's forwarded to the hardware development department, and there again based on special personal options
So to get this to here, right? We're dealing with people that are professional rock climbers, and probably somewhere mixed in there is a professional paraglider, as well as probably someone who's really good on a mountain bike, and then also someone who's an engineer or an arborist. Okay, so we're talking dozens of people.
Yeah.
By the time.
I think from idea to that, it's probably 6 to 8 people that work on
that have actually had their hands on the thing.
Yeah. In terms of design, in terms of functionality, production methods, application methods, practical validation topics.
Right.
So that's 6 to 8 people in our building. They're all internal people.
That makes a lot of sense. I'm glad to hear that the team is slightly smaller than I had originally thought.
Yeah, I know it's not that big.
It's a bit of a relief, to be frank.
No, it's like, but yeah, I would think it's 6 to 8 maximum.
Yeah, because I mean, like, obviously I'm not doing this at the scale that you guys are, but I'll come up with an idea and then I'll call my friend who's a machinist, and then I'll also call my friend that works at the bulk parts dealer. And I was like, all right, so now there's 3 people in there, you know what I mean? And then I call up my buddies over at wherever, because I need that one little piece of a thing that comes on that one thing.
Information is spread
but it is cool that 4 or 5 people, and before you know it, you have this new combination of geometry that can accomplish a task, right? Okay, well that provides me with the needed context to continue down the road of this device, because I've been always curious, like, how do we end up here, because I had met Flo, and I know Blair, and I had met Karsten, and then I met you, and I'm like, well, how do these guys, like, where does it all fit? It's cool to see how it all fits. So we have arrived though at a product now.
Finally.
This is ready to go.
Yeah.
Essentially in this form.
This is
Okay, so when are we shipping these now or soon, or are we talking Q1?
In terms of time range, we just finished certification some weeks ago.
But certification on the sport end?
Both.
Oh, really?
We directly did the certification for the sport standard, which is the EN 15151 semi-automatical belay devices or brake-assisted belay devices.
Yeah.
And we directly did the certification according to the 12841. So the rope access.
Okay.
And it passed all the tests, and
really?
Yeah. And now this was more or less, this is our confirmation. Now we say we can't change anything anymore,
right?
Because through the tests, only secondary elements.
And it's big money too to get it through the test, right?
Absolutely.
Yeah. Okay. So in that case, right now I'm looking at the sport print on this, and it's 8.6 to 10.5.
Yeah.
Right. So then this device gets tested in that range, because that's where people are sport climbing.
According to the 1551/1.
So the test decides the diameter.
Exactly.
Okay, so then now when we move into industrial,
12841, it's 10 and 10.5 millimeter the ropes.
But not 11.
No, 11 it failed in the strength test wet. It passes everything, but on a wet 11 millimeter rope, it doesn't pass the strength test.
Really?
That's the only exclusion. I have to admit that I'm not 100% sure what happened in the testing. I just heard that the wet static test failed. I can't tell what exactly was the mechanism inside.
But you said that it failed a strength test,
Only
the strength component.
strength test, yeah.
So that means it broke, or that means it didn't hold?
The rope broke.
Oh.
As far as I understood, the rope broke. Because in the strength test, you anyway have a stopper knot underneath.
Yeah.
And then a washer, big washer, and then you start to pull.
That's right. Okay. Yeah.
And usually it happens that there is a certain force transmission, or like the knot is sharing some force and the cam shares some force. And if this is not balanced, usually the one is camming too much or the other one has too much strength, and then one breaks.
And something's got to give.
This can happen on wet ropes. That this might be the.
Got it. Well, I suppose that does make sense. I just, there's other devices on the market that have a cam that are just known to slip.
Yeah.
Right. They just do. But then as soon as you put a knot, they can't continue to slip.
Yeah.
So something has to fail.
Exactly.
But then conversely, there's other devices that they used to be tested in such a way where you would fix both ends of a line, and then you would literally pull, rip the cam out.
In this case, you just test the structural strength of the device.
Of the device itself.
Yeah, and not of the mechanism.
That's interesting. Okay, cool.
Yeah,
so this is ready to go. Like this is the final iteration.
Yeah.
With the push button side, the single hinge, the added surface area to hold on to the device here. This does have anti-panic built in.
It does.
But it also has an option to delete the anti-panic.
There are actually two functionalities. The one is, imagine the situation you're in sports climbing.
Yeah.
Your lead climber is 40 kilograms and there's some friction on the rope.
Yeah.
What will happen when you lower, you will always jump into the panic mode.
And we scream at the device and we come up with really interesting ways to try to get someone to move, and it's a nightmare. Yeah.
And you just flip.
We've run into that in different rescue scenarios too. If you're not, so you can have a very high load, but you're not fully loaded on the system.
That's the point. If you're not vertical, free hanging,
or you're working on a ladder, or you're in a confined space or whatever, it just gets really difficult.
Absolutely. Or if the rope is really thick, old, dusty, stiff rope, then you always keep on ending in the anti-panic mode.
Right.
So what you can easily do if you want to have the panic mode, and still you're in the situation that you're always jumping into the panic mode, and you want to lower a lightweight person, for example, you can override it. It snaps into the panic mode, and then if you keep on pushing or if you keep on pulling on the handle, you open the cam without any transmission anymore. So it's a bit harder to find the sweet spot.
Yeah.
Nevertheless, in this case, you don't have a lot of friction or a lot of force on the rope.
Okay.
So you just override the mechanism and then keep on pulling, and by this you can lower also lightweight.
You're like force opening. You're actually reaching the end of the throw of the lever, and then it's the lever itself making contact with the back of the cam
and
forcing it open.
Exactly.
As opposed to it being, like you said, a transmission-based.
Yeah, you see
opening.
in the beginning when we start to operate the handle, you see that the handle is pushing forward this element, and by that the cam is getting pushed backwards.
Yes, I see.
So you have a certain transmission there.
Yeah.
And as soon as you override this, there is no more transmission. It's the direct force on the cam.
Right. So it's going to take a little bit more, but you don't have full load, therefore it's going to be just fine.
Yeah.
And now, so that's if you want to keep the anti-panic, but there's a way that you can delete the anti-panic entirely.
The second, if you know already that today you will work on a thick, old, stiff 10.5 millimeter rope and you're working on a slab, you're not free hanging.
Or you just want a device that doesn't have anti-panic.
Exactly.
Right.
You plan this, you know already today you will have such an application.
Right.
You can directly lock the anti-panic mode, and there you see the small hole here in the lever.
Yeah.
The device comes with a small screw that fits in there, and as soon as the screw is in there, you can see the handle can go to that point.
Right.
And then the screw hits the stopper here, and by that you cannot fall into the panic mode.
Right. Yeah. It just it literally just prevents it from getting to that position.
You have the first part of the transmission, and as soon as the transmission stops, you have the direct force transmission from the lever to the cam.
Makes a lot of sense. So now going into the usability of it, I do notice that this is rounded here, but this is obviously, this is where the rope is meant to flow.
When you're lowering.
When you're lowering. So doing this and having this ride over the edge and also, you know, over time twisting your rope up, this is to prevent that.
Exactly.
Right.
That's the idea behind it.
Just put it in the front. Okay, that makes a lot of sense.
It does work, or we found that especially on very thin or soft ropes, it's sometimes hard to find the perfect sweet spot. And then it's way easier if the pre-friction of the device before it runs into of the rope before it runs into the device is higher, then the sweet spot of the handle widens a lot.
Yes, of course. Yeah, this adds modulation.
Exactly.
Yeah, yeah.
And this is why we wanted to have this element here, especially for the very thin and soft ropes. So you guide the rope through this V groove here, which creates a lot of pre-friction already.
Yes.
It's like a tube.
Yeah.
And then the sweet spot of the handle is widening.
Yeah, it's like the sweet spot on a clutch. This is just adding, this is actually adding space on the throw. Yeah, yeah.
In case you have a very thick, stiff old rope, then you can easily run the rope sideways over the side shell. It works as well.
Of course, yeah.
And if you really run it in a way that the ropes almost touch, it does not twist the rope. If you run it like
if you run it this way, then it's adding that quarter turn.
It will twist.
But by going like that, the rope itself is just going like that.
It's just one big turn.
Yeah. Okay.
So if you have a very thick, stiff old rope, you can run it like this.
Yep.
And the very soft and thin rope are the easiest to work if you guide it into this V groove at the front and then maneuver with the handle.
It's brilliant. It's so elegant.
It's quite a small. It's a small detail, but it works really well, I found.
Well, I'm excited to actually put some laps on this thing for sure. To see this get certified into an industrial environment is going to be something else. Something that's this small and this tight, that is rad.
I'm quite sure that like the 90% of rope access technicians, they will still prefer the solid, massive device for 11 millimeters and thicker and loads up to 240 kilograms and EN 341 certified in rescue scenarios. Nevertheless, there are applications where I'm quite sure that the lightweight and small devices could offer an advantage. Like in this case, like route setters, for example, they are all over the world. Route setters are just reaching the point where they become professional workers from just like going to the gym and
having a hookup.
Throwing some holes into the wall.
Yeah,
it's
a job now. Yeah,
they start to work seriously, and they learn slowly. They start to learn the rope access techniques, and they start to work like in rope access. But they still come from the sports world.
Yes,
and they also often share like dynamic ropes and semi-static ropes, and you need a device for belaying, and you need a device for ascending, and you need a device for your tool bags and stuff.
Yeah.
So with this device, for example, for the route setters, it's the perfect match because they are still used to use sports climbing devices. Yeah. And still, they in the future world, they will need a 12-8-for-1 device. Right. And with this one, it's
going to be all in one.
It's the device.
I'm pumped, man. Good job.
Many thanks.
That's rad. Like, it's so cool.
I'm really motivated to see it on the market.
Cool. Yeah, as am I. And I think that, like you said, further iterations of this for specific tasks in the future, that's going to be something really neat. But I'm excited to see this thing go. You know what? I was just really happy to hear all of the context behind the scenes. Like, for me, that was rad. So thank you for sharing all of that. Thanks for sharing this brilliant new device and, of course, everything else here. And
really looking forward to hearing your feedback on this.
Yeah, let's find more stuff to talk about.
Absolutely, no problem.
All right.
I have some more in the shelf.
Cool.
Cool.
Well, I think that's all we've got for time. So
yeah, absolutely.
Thanks for the intro, and I guess maybe we'll hit the drop tower climbing wall zone and put some laps on this test.
On this one.
Cool.
Sounds great.
Thanks, man.
Perfect.
Sweet. Cheers.